On a standard map, a river appears as a simple blue line drawn across the land, a single, isolated path of water. But hydrology requires us to view the land as a massive funnel. When rain falls on a mountainous region, every drop that lands within a specific perimeter is caught and channeled downward through a web of interconnected tributaries until it merges into one main channel. This entire system, the main river and every tributary feeding it, is the river basin, and the total area it drains is its catchment area. These basins function as the chief agents of land erosion. As water flows toward the coast, it grinds down rock and soil, transporting massive volumes of sediment and waste materials down to the sea. These are active engines that physically shape the subcontinent, the primary forces defining the landscape. To map the true scale of this plumbing system, scientists utilized NASA's SRTM digital elevation data. Using a spatial resolution of 90 meters, they analyzed the terrain and divided the country into 25 major river basins and 103 subbasins. This map displays the result. It charts the major river basins of India, assigning specific zones based on the natural flow of water. Geographers classify these regions strictly by the size of their catchment areas. Rivers draining less than 2,000 square kilometers form minor basins. Areas between 2,000 and 20,000 square kilometers are medium basins. Anything draining over 20,000 square kilometers is classified as large. And as you can see, these large basins absolutely dominate the central and northern sections of the map. This map represents the structural blueprint of India. It prioritizes the natural flow of water over the artificial lines of political borders. At the top of this map are the massive Himalayan basins, the Indus, the Ganga, and the Brahmaputra. These are international rivers. Their tributaries cross through Tibet, Nepal, Bhutan, Pakistan, and Bangladesh. This data table of major rivers and their surface flow reveals the Ganga's massive footprint. Within the country's borders, its basin accounts for 26.2% of the total drainage area. Look down the table to the Brahmaputra. Its basin occupies just 7.8% of the land area. But the annual discharge column reveals a striking discrepancy. Though draining under a third of the Ganga's area, the Brahmaputra carries 33.8% of the total water volume. The Ganga drains a huge expanse of land, but yields a moderate relative water volume. The Brahmaputra drains a narrow section of land, but produces a towering volume of water. That surge of water comes from the intense rainfall localized in the northeast, turning this river into a high-capacity channel. Physical catchment area is a deceptive metric. Geographical location and topography are what ultimately dictate the actual availability of water resources. Shifting focus to the central and southern regions of the map brings us to the peninsular drainage basins, defined by major rivers like the Godavari, Krishna, and Mahanadi flowing toward the eastern coast. These peninsular systems operate on a different geological timeline. They are much older than the volatile Himalayan rivers, carving through stabilized terrain that has settled over millions of years. Looking at the surface flow data for these rivers, like the Mahanadi and the Narmada, shows moderate, stable annual discharge percentages without the extreme volume spikes seen in the northeast. These ancient basins function as the reliable, steady geological plumbing of central and southern India. While the general tilt of the land directs most water eastward, the map explicitly isolates regions on the western coast. These are the west-flowing rivers, including the Narmada and Tapi, cutting directly toward the Arabian Sea. Finally, returning to the data table reveals the collective power of the smallest rivers. Code 15 aggregates all the medium and minor rivers. Though individually small, together they account for 23.6% of the country's total basin area. The largest rivers dominate the map, but the vast network of smaller geographic capillaries provides the underlying water security for a quarter of the landmass. The hydrology of India operates in two distinct modes: the young, high-volume rivers plummeting from the Himalayas, and the older, steady rivers draining the peninsular plateaus. Those systems naturally overlap. Ancient peninsular rivers like the Chambal and Betwa still flow northward, ultimately feeding into the newer Himalayan networks. To understand land erosion and the distribution of resources, you have to look past political borders to the permanent architecture of the river basins.